Okay, I'm continuing from part 2 of the recording. So just like I already explained what is polarization, so now I'll go on to explain the factors that affect the extent of polarization. Okay, so we have to look at the cation. Basically a cation with high charge density is strongly polarizing. Okay, the definition of charge density is charge over size. Okay, there's an amendment that I want you to make in your summary notes. Okay, so it's not charge over mass, it's charge over size. Size meaning the radius or the volume. So basically charge density tells you how concentrated the charge is. So for example, you can have two ions, they have the same charge, okay, but the smaller ion will have a higher charge density. So in other words, the charge is more concentrated in a smaller ion. Okay, so I think this one is really quite intuitive. So if the cation has a higher charge density, the charge is more concentrated, it will be able to attract or polarize the electron cloud of the anion more easily. Okay, the next one is regarding the anion. Okay, so anion with high charge is easily polarized. So this is similar to the cation, also quite intuitive. So if the anion has high charge, okay, that means the attraction between the cation and the anion is stronger. Okay, and therefore the anion is more easily attracted or more easily polarized. Okay, this one, an anion with a large radius is easily polarized. Okay, this one is different from cation. So for cation, you need a small size or high charge density for the cation to be strongly polarizing. Okay, but for anion, it's a large radius that will cause the anion to be easily polarized. Okay, the reason is this. In a larger anion, the distance between the outermost electron and the nucleus will be greater, right? So as a result, the outermost electron are more loosely held by the anion. The anion will have lesser control over the outermost electrons if the anion is very large. And as a result, these electrons will be easily polarized, easily attracted towards the cation. Okay, so now if we look at part C, the reason why silver iodide has a larger amount of covalent character is simply because iodide is bigger than fluoride. So in other words, iodide is more easily polarized by fluoride, and hence silver iodide will have greater covalent character. Okay, so that's why the experimental and the theoretical values are more different. Okay, so that's the end of the recording for Tuesday's HBL lesson.